Section B, question 7. So we have a ballet company performs this show every year, and last year they gave a total of the 60 performance at their theater, and which has the maximum capacity of the 800. So this is the ticket number, right? And the number of the tickets sold and at each performance is shown in the following frequency table. So we have a frequency table here. So question AI, we need to find the value of the P. So P is here, and then this refers to the number of the performance, and then the total number of the performance is 60. So means when we add all these numbers, it should add up to 60, right? So the P value is same as 3 plus P plus 18 plus 30 equals 60, and P value is same as 60 minus 3 minus 18 minus 30. So it is same as 9. Then question AII, we need to write down the modal cost. Okay, so modal cost means the cost that has highest frequency. So we are referring to 600 to 800 as it has the frequency number of the 30. Then let's look at this frequency diagram. Okay, so question B, we need to use the frequency curve to estimate the median number of the tickets that were sold, right? So we know the total number of the frequency is 60, as you can see that it reaches the maximum point at 60. Okay, that means we need to do 60 divided by 2 to find the middle number, right? So we are looking at 30 as a center. Then we have to figure out where this 30 meets the graph, and then where this point meets on the x-axis. So we can see that the median value is 600. Okay. Then question BII, the number of the performance where at least 80% of the tickets were sold. So we first have to figure out what is the 80% of the 800 tickets. So we calculate 800 times 80%, which is 0.80, and this will give us the value of the 640. So at 640, which is this point, we know that the 80% of the tickets were sold, right? So we have to figure out where this 640 meets on the graph first. So it goes all the way up, and we know that it meets at this point here. That means on the y-axis, it meets 40, okay? So means since we need to calculate the number of the performance where at least 80% of the tickets were sold, we are referring to this part here, okay? So we know that we have to do 60 minus 40, and 20 is the performance, number of the performance where at least 80% of the tickets were sold. Okay, so question CI. So we need to state one disadvantage of the company surveying only the first 5% of the audience as they leave the theater, right? So this method is very disadvantaged because it is biased sample, right? The survey is not really based on the whole audience. It's just based on the people who were likely to be in the same part of the theater. So the survey result is very biased, and also it is the method they are using is convenience sampling method. So the result is not really accurate. Then CII, we need to describe briefly how the company could collect feedback from the 5% of the audience using the systematic sampling method, right? So systematic sampling method means that we need to have an interval when you choosing the sample, right? So since we have 800 tickets so far, right? Then if we choose every 20th person, then we will have a sample using the systematic sampling method. Then CII, we need to state the sampling method which should be used if the survey is to be representative of the number of the children and number of the adults in the audience. So we have a subcategory, and these are non-overlapping groups, right? Children and others, so they are not overlapping. So non-overlapping groups. So means we are using quota sampling method. Okay, so last year 36,000 tickets were sold to the nutcracker. So question D, the following box and whisker diagram displays the amount of the spent by the audience at the souvenir shop when they attend the performance. So here we have a Q1 value, Q2 value, and Q3 value at the lower boundary and upper boundary. So DI, we need to estimate the number of the people who spent between $3 and then the $25. So we are referring from here to here, right? So this is from the Q1 to the upper boundary. So means Q1 refers to the that middle or the 25% of the first half, right? So means this part here is 75% of the people. So we have to do 75 times 36,000, and this will give us the value of 27,000. Then DII, the half of the audience spent less than $8. We need to estimate the value of the A. Okay, so 50% on a box and whisker diagram refers to Q2, right? Q2 is a median value, so it means it's the middle value, right? The center. So we can say that A is equal to 7. Okay, then question EI. So this year the company will again give 60 performance and expect to sell 17 additional tickets for each performance, right? So question I, we need to calculate the mean number of the tickets the company expects to sell this year for each performance. So to solve the question I, we can use two different methods. First method is you can just calculate the mean all over again by doing 36,000 plus 17 times 60, because we are adding 17 additional tickets for each performance, and there are total 60 performance, right? And divide the whole thing by the 60, and this will give us the new mean value of 617 tickets. Or we can also use the method such as, since we know that old mean value is 600, when we to calculate the new mean, like since we are adding same number of the tickets to every single performance, that means the increasement is by 17, right? So we can just add 17 to the 600, then we can calculate the new mean of the 617. Okay, so that's also another method that you can use to calculate the mean value. Okay, question EII, we need to state what effect, if any, this increase in ticket sales would have on the variance of the number of the tickets sold for each performance. We have increased the same amount of tickets for every single performance, so there's no big changes, so there's no effect on the variance. Question number 8. So this is a natural log question. So this means it is derived from the topic 2, the functions part of your curriculum. So we have information. The f of x is same as natural log 2x minus 9, where x is greater than 9 over 2, and g of x is same as 2 natural log x minus natural log d, where x is greater than 0 and then d is. So question A, we need to state the equation of the vertical asymptote to the graph of the y equals g of x, right? So to talk about the vertical asymptote of the any like natural logarithm or logarithm, we need to know that the particular asymptote refers to what's inside of that number, right? So if we say we have log a bx plus c, we can calculate the particular asymptote using this part here, okay? So to calculate the particular asymptote, we have to set bx plus c equals to 0, and bx is same as minus c, then x is same as minus c over b, and this is your particular asymptote, okay? So same thing with the question A. Since we need to calculate the particular asymptote of the function g of x, we know that g of x is same as 2 natural log x minus natural log d. We don't have to worry about this part here because this is going to be a constant or number. However, to calculate the particular asymptote, we have to look at this x value here. And natural log ln is same as 2 times log e x, right? So using the what's inside of the number, which is this part, and then set it equal to 0, we know that the particular asymptote is same as x equals 0. Okay, then we have new information. The graphs of the y equals f of x and y equals g of x intersect at two distinct points, right? So question BI, we need to show that at the point of the intersection x squared minus 2dx plus 9d equals 0, we're going to set, since we are talking about the point of the intersection, we are talking about the case where we have f of x equals to g of x. So we can set ln 2x minus 9 equals to 2 ln x minus ln d. Okay, this is same as ln 2x minus 9 equals to ln x squared. I moved the 2, right, using the logarithm rule, and this is also same as ln x squared over d using the quotient rule. That means 2x minus 9 and x squared over d is also equals to each other. Then using this information, we can say d times 2x minus 9 equals to x squared. Then 2dx minus 9d equals x squared. Then x squared is same as x squared minus 2dx plus 9d equals 0. So we have shown that at the point of the intersection, x squared minus 2dx plus 9d is equal to 0, QED. Okay? Okay, then let's talk about BII. Hence, we need to show that d squared minus 9d is greater than 0. So means we need to talk about the discriminant, right? And since we have two distinct points, discriminant needs to be greater than 0. So we are using the quadratic equation from the question A. So it's x squared minus 2dx plus 9d equals 0. And discriminant is b squared minus 4ac and needs to be greater than 0. And from this quadratic equation, we know that a value is equal to 1, b value is equal to minus 2d, and c value is equal to 9d. So substituting these numbers into the discriminant will give us minus 2d squared minus 4 times 1 times 9d greater than 0, and same as 9d squared minus 36d greater than 0. Then simplifying everything using 4 will give us the value of d squared minus 9d greater than 0. So we have shown that d squared minus 9d is greater than 0. Okay. Then question B, we need to find the range of the possible values of the d. Okay. So we already know that d squared minus 9d is greater than 0. So let's factor this out, right? Then we have d times d minus 9 greater than 0. That means d is greater than 0 or d is greater than 9. Okay, so we have, since the d value always have to be positive real numbers, it cannot be greater than 0, but it can be greater than 9. So the range of the d is greater than 9. Here we have a diagram that shows the part of the graphs of the y equals f of x and y equals g of x. And the graphs intersect at the x equals p and x equals q. So you can see them here. These are the intersection points. So question C, in the case where d value is equal to 10, we need to find the value of the q minus p. Express our answer in the form of a square root b, where a and b are positive integers. So from the previous question, we know that our equation is x squared minus 2dx plus 9d equals 0. So let's use this equation. So x squared minus 2dx plus 9d equals 0. And we're going to substitute 10 into our equation. And this gives us the x squared minus 2 times 10 times x plus 9 times 10 equals 0. And it's same as x squared minus 20x plus 90 equals 0. Okay. Since we need to factor this out to find our x values in order to identify the intersection points, I am going to use the completing the square method to just simply solve this question. So we can first separate the first two terms like this using the square. Then this is same as x squared minus 20x plus 20 over 2 square minus 20 over 2 square plus 90 equals 0. Then this is same as x squared minus 20x plus 10 square minus 10 square plus 90 equals 0. Then using a squared minus 2ab plus b squared equals a minus b square rule, we can simplify this into a x minus 10 square minus 100 plus 90 equals 0, right? Then this is same as x minus 10 square minus 10 equals 0. And this is same as x minus 10 square equals 10. Okay. Then let's try to factor this out. Okay. So this is same as x minus 10 square equals 10, which is same as x minus 10 equals square root plus minus square root 10. Okay. Then this is same as x equals 10 plus minus square root 10. And since p value is less than the q value, the q value is same as 10 plus square root 10, and p value is same as 10 minus square root 10, right? Then q minus p is same as 10 plus square root 10 minus 10 minus square root 10. This is same as 10 plus square root 10 minus 10 plus square root 10. So we get 2 square root 10 as our final value. So we can say that the A is equal to 2 and B is equal to 10. So we have presented our answer in the form of the 2 square root 10.